Welcome. This is going to be Unit 1.2.5, talking about work, energy, and power. So first we got to talk about what is work. Work, symbolized by the letter W, is force times distance. Now, remember that the force is going to be parallel to the distance. Do not get that confused with the perpendicular, which stands for torque. So work is in the parallel. That's what the symbol represents. They have to be in the same direction. Now the SI unit for work is a joule, or Newton meter. Joule is the standard one. Now here's an example. A student lifts a 50-pound ball 5 feet in 5 seconds. How many joules of work did they do? So that one is just force times distance. 5 times 4, or 200 foot-pounds. This is how much work is done, but this is not in joules. Foot-pounds is not a joules unit, so we convert that into the SI units, converting pounds into newtons and feet into meters, and multiply those two numbers, and that gives us 271 joules. Now, energy is the ability to do work. So light energy, heat, mechanical, chemical, there's so many different types of energies and how to get those energies using fuel cells, solar cells. You can use even the roller coaster itself has energy. So there's different forms. There's potential energy and kinetic energy. Potential energy is stored up energy, energy that is going to be used eventually. So that's stored up either in chemicals, in the form of like sand oil here, or maybe nuclear energy stored up in the nuclear bombs, or stored up in other forms. Then you have kinetic energy. This is the energy of motion, of movement. So this is where the energy is coming from something moving, such as water, wind, or the actual object flying. Energy transfer. We can transfer energy from one side to another. For instance, you eat your food, it turns into kinetic energy. The sun produces light energy, and plants absorb it and turn it into chemical energy. Electrical energy then is turned into heat energy via your oven. So these are the renewables. We already discussed these, but they do exist. Non-renewables are like your natural gases, your uranium, your coal, and your petroleum. Those are going to be used up, and if we used up all of those natural resources in Earth, they can't be remade. So why is this important? Well, we have to know about conservation of energy. We cannot create nor destroy energy. Energy can only be lost if it's through heat. Heat still being a type of energy, but it's not lost as in it's never gone. It just evaporates off into space. So, for an example, we take fossil fuels, that's a form of gasoline, that's chemical. That turns to heat, which then drives the car forward mechanically, which also charges your car's electrical systems. These are the different types of conversions. Now, efficiency is how well can you get those energies in. So you put energy into the system, how much can you get out? And so the efficiency equation is energy out over energy in times 100. So, if you can look here, here is some energies that we use in the United States. Biomass in the United States was only 2.9, hydropower is 2.7, geothermal 0.3, wind is 0.1, and so on and so forth. If you notice, coal and natural gas and petroleum are well over all of the others. And that is because they are so easy and inexpensive to use. Power, though, is the energy over time, how fast we use up that energy. And unit is the watt. So electrical power uses electrical energy to do work. Mechanical power is using physical motion of moving something. And fluid power is transferring hydraulics or gas pneumatics power. So let's look at the same problem again. A student lifts a 50-pound ball 4 feet in 5 seconds. What is that in units of pound-feet per second? Okay. Now this one shows you in joules. So we took the 271 joules from earlier, and we divided by the time, and that gives you 54.3. And that's it. Thank you and have a great day.